We spent plenty of time in class talking about matrix inverses and actually what they are, but we haven't spent much time just finding them, practicing finding them. So I wanted to do a couple of examples of how we actually find a matrix inverse. Here I've taken our good friend 1, 2, 3, 4. This is the matrix I've been using for a lot of examples, and I want to find its inverse matrix. Okay. And the inverse matrix we've seen can be found using this formula. Now, this is a complicated big formula. When I'm using it, I like to split it into two parts. Okay, I like to do this part first because it's nice and easy. It's relatively easy to find. If my original matrix A is A, B, C, D, then in the inverse matrix, the A and the D will be in opposite positions, and the B and the C get made negative. So that's a really easy part to do. The bit where it gets tricky is with this sort of mess out the front, this 1 on AD minus BC. And it's really important that we're up to speed on our order of operations and how to simplify expressions with numerals in them if we want to get this right. So let's have a go at applying this formula to this matrix here. A is 1, 2, 3, 4. We want to find the inverse matrix. Okay. First thing I want to do is I want to be aware of what my A, B, C, D in this formula refer to. So the A, B, C, D are each of these elements. 1 is A, B is 2, C is 3, D is 4. Okay. And my inverse matrix is going to be found. I'm going to leave this part out for the moment. I'm just going to put in here, D needs to go into this spot. So my D is 4, it's going to go in the top left. B is meant to be negative B, so currently it's a 2, it needs to be a negative 2. C, it should be negative C, so it's negative 3 goes in here. And the last spot, the bottom right corner, is A from my original matrix, which is 1. So that's the first part of the inverse matrix. The second part is this factor that goes out the front. Now it looks quite large, but it's in fact just a constant, a scalar value, 1 on AD minus BC. This is just going to come up with a number, and when I'm calculating this, I sometimes just like to go to the side to work it out. So let's have a look at what this is going to be. 1 on AD minus BC. Alright. AD. Well, that's A times D. A is 1, D is 4, so A times D is 1 times 4, which is 4. Now we'll think about this. B times C. B is 2, C is 3, 2 times 3 is 6. We need a negative sign in between. So I'm getting 1 on 4 minus 6. Now, we've got to do the numerator first. We've got to tidy this up. 4 minus 6 is minus 2. So I'm going to get 1 on minus 2. I can also think about this as negative 1/2. Okay, they're the same expression. Okay, there's a few different ways you can show that, but have a think about that if you're not really sure why that's the case, or come and ask me in class if you'd like an explanation why that's the case. But this here, this 1 on AD minus BC is going to simplify to minus 1/2. So this is what I've got to put out the front of my matrix. So I'm going to put that in here, minus 1/2. And we probably don't want to leave our matrix in this form with a constant out the front. So we need to expand, we need to multiply this constant inside. So we need to multiply by each element of the matrix. So I'm going to simplify this by going minus 1/2 times 4. Then I'm going to go minus 1/2 times minus 2. Minus 1/2 times minus 3. Minus 1/2 times 1. Like that. We're going to have to tidy up here. Minus 1/2 times 4 is going to be minus 2. Minus 1/2 times minus 2. Half. Okay, let's think about what's happening here. Two negatives, a negative times a negative is a positive. a half times 2 is going to be 1. So it's going to be positive 1 in this spot. Minus a half times minus 3. Again, two negatives multiplied together are going to be a positive. Half times 3, I could write it as 1.5, but it's preferable if you're doing a half times 3 just to leave it as an improper fraction. The way to do that, think about 3 as 3 on 1, and we multiply along the top and along the bottom, so we get 1 times 3 is 3, 2 times 1 is 2, so it's 3 on 2. Okay, positive because we've got two negatives multiplied together. And finally, negative a half times 1 is just negative 1/2. And so this is the inverse matrix of the matrix 1, 2, 3, 4.